Dr. Rico here. This is a lecture from my mini course, Robotic Planning and Kinematics. The syllabus and notes are in the description. All right, so Chapter 6, Introduction to Kinematics and Rotation Matrices. An introduction, this lecture. This chapter begins our discussion of two interconnected topics of kinematics and rotation matrices. Kinematics is the study of motion independent of the force causing it. In kinematics, one is concerned with describing the motion of objects by relating positions to velocities, i.e. via differential equations of the first order. While it is simple to relate the position of a point to its linear velocities, relating the position and orientation of a 3D object to its linear and angular velocities is less obvious. Kinematics is not to be confused with dynamics, where Newton's laws is adopted in dynamics, that is, to explain how velocities change in time. We will not discuss dynamics in these notes. In kinematics, we study how to define and manipulate the following. 1. Body positions and orientations. 2. Reference frames and changes of coordinates. And 3. Rigid body motions and their composition. Rotation matrices are a powerful modeling tool with multiple applications. First, the set of rotation matrices is the configuration space, or part of the configuration space of any object that rotates. Okay? Recall, rotation being the key there, recall our discussion about configuration spaces in Section 3, Chapter 3 of these notes, configuration spaces. Therefore, by understanding rotation matrices, one can then use the motion planning algorithms in the first part of the course to plan the motion of three-dimensional objects such as aerial, space, and underwater vehicles. Additionally, rotation matrices can be understood as transformations that rotate objects and play a central role in modeling reference frames in space. In short, rotation matrices are a fundamental technology in numerous disciplines in engineering and science, including, for example, robotics and aerospace engineering, the orientation of robots, aircraft, underwater vehicles, satellites, etc. 2. Medical sciences, modeling of eye movement and of the vestibular system. For example, see Allison, Eisenman, and Chung. 3. Computer vision, orientation of cameras and objects in the scene. And 4. Video games and 3D virtual worlds. See Lewis and Jacobson, Carpin et al., Epic Games Incorporated, etc. All right, so that's the introduction, and I'll see you next time.